Welcome to week 3 of the Beginner Boost, the SKILSTAK Beginner Boost. We are going to be covering a lot of fun stuff today. We're going to be going fast. You're probably going to be pausing the video because we're going to cover a lot of stuff. In fact, this is take 2. I actually did the whole thing and I ran into some hiccups during the thing. Good ones, though, that I was able to work out. So we're going to do another quick version of this so you can just get what you need and go. And I will tell you the failures that I made as I hit them and the things that we learned the hard way as we go, so that you don't lose out on me watching me fail. I'll just fail faster so you can faster. So what is the goal for this week? So this week we have 2 hours and we're going to try to get through all of the following. I'm going to summarize it really quick. So we're going to get Ubuntu Linux running in a container. We're going to get it set up. And we're going to get it set up in every way so that by the end of today, you should be able to do whatever you want with that container and save it and publish it and share it online, even at GitHub as a package. And you can pull it down anywhere you want that you've got Podman installed. And you should be able to navigate around the command line. You should know how to create a basic user, get a baseline Ubuntu image up and running with all of its documentation. You should know generally about, what's in the file system, what, you can generally describe what the different baseline directories are in the image, and just have a general sense of what Ubuntu is and why you're using it. Okay. And then next week, we're going to start getting into the creation of content, creating scripts, creating, starting to create files and understand how that works. We'll understand by the end of today, we'll understand what a file is in a directory and how to move around about them. And, but we're not going to be doing a lot of creation of files. Okay. So we're just going to be talking about how to inspect the system and how to get help after having set up the system. That is the goal for today. So we're going to move pretty quickly. Again, we have to stick with the 2 hours thing. So the first topic right now, and I spent about 30 minutes on this in the first take, and I am not going to do that now. Okay. What is Ubuntu? And you can actually go out on the internet and do a search for that yourself. You're, smart people. I don't need to tell you what that is. All right. So, and I'm not going to go deeply into the history of it. So suffice it to say, Ubuntu Linux, and let's just do a search so you can look at it. So we'll have a visual aid. Ubuntu Linux. Ubuntu Linux is a Linux distribution. There are many of them. We've already talked a little bit about what Linux is, and I'm going to avoid really hitting the whole where does Linux fit into the ecosystem, which I did for like 40 minutes today, 30 to 40 minutes today. And what the bottom for now, Ubuntu Linux is the leading Linux distribution for use in containers. And you can fight with me over that in Discord all you want, but if you're especially, the boost is for beginners, and I can justify that statement all day. Okay. And I'm talking about Ubuntu server. Please be careful. I'm not picking fights with Arch users and, X and such other Linux distribution. Like, well, what about Red Hat? Enterprises love Red Hat. Yeah. Red Hat is the preferred distro for host hardware. So if you got a brand new machine and you're an enterprise and you want to have all the wonderful thing that comes from having a corporation behind you, you generally will go with Red Hat. But if you are spinning up a container in the cluster, or you're spinning one up in the cloud, or you're watching a you're watching a tutorial or something, 9 times out of 10, they're going to be using Ubuntu. And there are lots of reasons for that. But the primary reason I would suggest is that Linux server APT that comes with it, which we're going to get into, stands for the advanced package something. What is it? I forget. But it's a package manager. It's a way of distributing and installing software. Is probably the easiest to use and the most intuitive, and it's been around the longest. It's built on Debian Linux, if you want to know about that. So the only thing I'm going to say about what Ubuntu Linux is is that it's the primary container distribution for use, and it's very, very user friendly, and for that reason, it's really, really beginner friendly. So Linux Mint and everything. That's the only thing you need to take away from that. We will go pretty deeply into how Linux relates to Unix, like FreeBSD and all that. Not today. Okay, not today. We will do that, just not today. That is going to come when we talk about the Unix philosophy, where the whole Unix approach, the whole why do we have commands and all of that stuff, right? We're not going to get into that a lot today, and the reason for that is because we just want to get busy starting to do stuff. When we talk about that, we're going to specifically talk about that in the context of something called Unix filters, which is what makes Unix, one of the things that makes Unix so powerful. Okay, so that's kind of a spoiler alert, but I don't want people to think I'm just skimming over it. We are going to cover it. I just don't think we're going to cover it right now. Okay, so the first thing, why Ubuntu, as I just told you, it's because it's the leading container image. So the first thing we need to do with this is we need to pull Ubuntu Linux container. So if you want to by the way, take a moment. I hope you have your notes open in GitHub. You're using right now, you're just using you should be using the GitHub interface to edit your notes in Markdown. We covered that on Nick 1. So, take a moment right now to write down why we're using Ubuntu and put the links out there. If you want to take a homework assignment or extra credit or whatever, you can go do some research on why it's there. How come it's the leader? Is it the leader? What do people say about it? All right. That's your takeaway from that. Now we can go on into the next thing, which is getting it. Now we've already done the podman command. We already have git bash installed, right? And so just a reminder, the thing you're looking at here is Windows Terminal customized with my Groovebox theme, all of which we've discussed in previous weeks. And I am using the command prompt from Bash, which is my current Windows user, my current host name for my Windows machine, and the tilde, which indicates my home directory. Okay, so just a reminder on that. So PWD will tell you in Windows, I am in C user Rob. Okay, so I am on Windows right now, even though it looks like I'm on Linux. But what we want in order to do this is we want to have true Linux. This is why we installed Podman. We're not going to go through installation. You should have it already. And so if you're not got Podman yet, you need to stop the video now and go back and do that. So we're going to do Podman, and the first thing we're going to do is we're going to pull down the Ubuntu image, Linux image. Okay, now I am deliberately using the simplest, most memorable commands. If you know the longer version of this, fine. Don't bother with it right now. This says pull Ubuntu from the default registry, which is Docker Hub, and get the default Ubuntu image. Okay, so this grabs the most recent image from docker.io library Ubuntu. Right there, you can see here it fully qualifies the path to that image, which will come in handy later when we push stuff to GitHub instead of to Docker Hub, which is hub.docker.com. Okay. But for the sake of simplicity, we're just going to use the defaults. Somebody asked me at this point earlier if the podman commands were identical to the Docker commands, and the answer is mostly yes. So anywhere you see Podman, you can, if you've done Docker Desktop instead of Podman Desktop, you can usually use Docker pull. Another reason to know that is because a lot of times the documentation, like for example on GitHub, will document it using the Docker command and not the Podman command. And in every case that I've encountered so far, you can replace Docker in that case with Podman and be fine. All right, so okay, so the next thing we're going to do is we got Ubuntu, right? But now we need to run it. So we got an image. It's been pulled down. We can actually look at our images with the pod. Write these in your notes. We have Podman images, and this will show us all of our images. Now I have a lot of them. Don't freak out. So, but you'll see some of these are local hosts. We're going to figure out what that means in just a bit. And then we have these remote ones, right? And here's the one that I pulled down, right? And it says it's the latest. It says it's 3 weeks ago. Some of you may be wondering, Mr. Rob, but you already had it. Why did you pull it again? Why would you ever do that? Because if a new one has been published and you do pull, it'll get the latest. And that's what the latest tag means, right? You can have tags that have versions in them and get the specific version of an image if you want to. but just by default, it will get the one that says latest. And sometimes it'll get added to the end here. See that? So that means it's the latest. And that'll come in handy later when you get into this. But now we're just starting up. So the Ubuntu image by itself is pretty small. As you can see, my workspace image, which is Ubuntu, is 2.16 gigabytes because I've added a lot to it. So the reason I wanted to show you this is because images by default, generally speaking, are small. And that's because the idea of containers is not so much to be a replacement for virtual machines the way we're using it, but it's usually meant more to give you the minimum necessary to run some specific application that's been, all containerized up and then can be shipped off to be run in any sort of container engine world or Kubernetes. That's the point. We just happen to be piggybacking on container infrastructure to learn the terminal in a way that's sort of lightweight and lets you go around all over the place. Yeah, people will groan when they see a 2 gigabyte image, and I don't even want to know what they would say at some of our 10 or 20 gigabyte images we have in our Harbor registry at work, because people put all kinds of stuff into their images. And images can get bloated pretty quickly. It becomes really annoying when images are too big because they're hard. The idea is that you could pull an image really quickly, spin up 1 or 2 or 10 containers and run them and make them all go away. So the bigger they are, the less liquid they are, the less So I architecturally, having a big, huge image is usually not what you're going to encounter. People will roll their eyes at that, but I believe that making a workspace container image that is bloated and has all your fancy stuff in there is justified. And I will cite something that happened at work recently this week. Actually, we were in the middle of debugging some other stuff. And by having a workspace container image in the Kubernetes cloud, we could pull that workspace with all my favorite tools in it and everything like that. I mean, that's the idea. Somebody else did theirs this time, but I have one too. And they pulled that image into the Kubernetes cluster so that they could use all of those tools at that location. And we had to do a bunch of network diagnostics. One of our entire subnets was not functioning properly. And that would be an opportunity it would be nicer if it was a really clean, small, network utility container. And there are containers that have that. But if you have a preferred workspace, the really great thing about building up a workspace container is you can use it anywhere. And you're going to see this more by the end of the day. You'll be able to download your workspace container anywhere in the world and into any Kubernetes cluster or any other thing and use it. And that way you have it to go with you. It's like Linux container can travel and you can work anywhere with your preferred things, whether it's your own laptop that's running, Podman desktop, Windows or Mac, or if it's, inside of a Kubernetes cluster, or it's inside a cloud, or it's inside of a batch environment that allows you to spin up containers. In any of those environments, you can take all your favorite tools in one nice little container image and you can use them. Okay, so that's why we're sticking with containers, and we probably will be for the foreseeable future. So we've got this image. Now let's do the next thing. So the next thing is we want to actually run it, right? So we're going to do run IT, and remember, how do you look up the help about Podman if you don't remember it? Podman -- help, right? This will tell you all the commands, or you can do run -- help, right? That'll show you the commands. And yes, I'm scrolling because this is Windows, but I'll show you how to get around that. And there's some reading for you to do there. You don't need to understand all of it, just the commands for today. So we're going to go ahead and do run and then it. Now that stands for interactive terminal, or TTY. T actually stands for TTY, but if you just remember run -it, you just won't have to worry about it. And if you wanted to throw the container away after you were done with it, you could just do --rm. Like, for example, let's just spin up an Ubuntu one. This just runs an Ubuntu one, right? And then I exit. And the container that it created from the image was immediately thrown away. If I didn't do that, this is what you would get, right? And then when you do exit, then you do podman ps, and you'll see nothing's running, right? But if I do podman PS, which stands for process, or otherwise running container. There's a container, but it's not running right now. -A will show you all the containers, even if they're not running. And there's a lot of them here because I've been working on it. But you'll notice the last one down here is an Ubuntu latest. That's the image it came from. This is its unique identifier. This is the default command to run, which is the bash shell, same as git bash. And you can see that it exited 17 seconds ago, and it gave it this completely random name, Goofy Solomon. Okay, and that's stopped, right? And you'll notice that it left it around, right? But watch what happens when I do it with RM. If I do it with RM, it'll start up, and I type exit this time. And this time when we go look at our containers, you see there's no new container created because it immediately cleaned it up, right? And the idea of cleaning up containers that aren't being used is pretty common. We won't be doing a lot of deletion, but if you wanted to delete it explicitly, let's go through that command. Write all of these down in your notes. And I should probably put this in my notes too. Actually, let's modify my notes really quick because I'm adding another command that I hadn't showed you before. So we did. Let's see. Create it within man. Look at images. Yes. Exit container. Restart attached. Yeah, we're gonna do that. Understand difference between running and exited containers. Use --rm for temporary containers, and let's do use podman rm let's see, use podman ps-a to show all containers, and running and exited as opposed to stopped. I mean, stopped is another way to put it. And let's say use podman rm to remove unwanted containers. Again, a container is an instance of an image. That means an image that was started up, that was running at one point. And it can be stopped, but once you start one, that creates an instance of that thing. All right, so let's actually do that. So podman rm, and we can use the name here. Actually, this is one of the reasons that we installed git bash, because we can now use tab completion. In fact, I want to put that in the notes. Okay. Use let's see right here. Use tab completion in git in bash. Actually, we could use bash tab completion to save on typing. You want to get in the habit of doing this all the time, not just here. Okay, so we can do this. We can say podman podman rm tab, and when I hit tab twice, it showed me all of them because I didn't give it any hints, right? So there's lots of these random names. Now, we happen to know from our ps-a that it was this last one. We know it begins with Goofy, right? So I could type G tab, and it will complete with all of the things that start with G. And as soon as it gets to unique, GO tab, it'll give me the actual name. So that saves on typing. And so then you can do that. And now you'll see podman. Oh, by the way, I'm making sure I write this stuff down, even if it takes us longer. So use up and down arrows for now to get previous commands. It's called command history. We're going to go through it thoroughly, but for right now, I just want you to know that you can put the up arrow, you get the previous commands, right? So podman remove, we already did that one. Let's go keep pushing up. And I said podman ps-a. If you don't want to type it again, you can do that. And you can see that container is now gone, right? It's not there anymore. We deleted it. I need to delete some other containers really quick while we're doing this. So I'm going to go ahead and remove the boost container. And I'm going to remove boost week 3, RTX Rob, and boost. I think we have another one. In fact, you can remove them all if you want, because they do take up space, but that's fine. So, and by the way, podman ps shows us that nothing is running right now. All right. So back to our container. We talked about how to do temporary containers with RM. We talked about listing the running containers. We're moving unwanted ones using tab completion, up and down arrows. Okay, now let's actually spend a little time making a container that has a name that we can reuse. All right. So for the sake of the boost. And so this is the command you should write in your notes. And clears the screen, and we'll talk about that later. So podman run, all right, IT. So that's going to give us a connection, right? And we're going to actually give it a host name. Now, a host name is different than the actual name of the container. Remember the random name it gave us? The host name is the thing that appears in the prompt. So right here it says TV, right? And we want that host name to not be that big, ugly, random thing. We want it to be something that looks pretty and that, you know, can be referred to and stuff like that. So we'll do -- host name. These are all in the Podman docs if you look them up. So we want host name, and let's call it boost. And then we will call it name boost. Now these are the same, but you'll see this boost name is, we could do boost 1, boost 2, that kind of thing, right? So in fact, let's do that. Let's make the name boost 0. Okay. So that means it's because we're going to make different versions of this container. Actually, no, let's just call it boost. That's fine. And then what? And then we need the name of the operating system. And if we wanted to, we could put the program to run, but we are going to use the default, which has been bash. So let's digest this. We're going to run podman. It's going to run a container. That means it's going to make a new container from the base image. And that image's name is Ubuntu. And it will resolve that by looking locally and then looking at the default on docker.io hub if it doesn't find it. We could write the big, ugly, hairy, long name if we wanted. We don't need to. We can put the host name here, which again will give us this part of it right there. That has to be done during start or run. It cannot be done any other time. And then we have this here, which is going to give us, instead of having a random container name, it'll give it now. That's the name of the running container. This is the name of the host machine, we'll say, but this is the name of the container. And even though they're the same, they are different names for different things, even though it's the same name. All right, so here you see we get, you'll notice the prompt has changed. So instead of it being Rob, we're now root. Root is the default administrative user on containers. If you know about containers and privileged users and all that stuff, we're not going to get into that. Just know that by default with Podman, when you run a container, it is going to run with root administrator permissions. Now, if you're a hacker, you'd be like, yeah, baby, I got root, got root. But we're going to actually change that almost right away. But let's talk about the prompt a little bit. So this here is boost, and that is the name. That's actually the host name that we gave it. And here you see that the pound sign. We talked about that weeks ago. That means that I am on a privileged shell. That means I am running as root. When you see the prompt of a hashtag, it means you have a root access. Okay. Well, we already know that because it says root user here, but there are circumstances where the user might be something else and you would still have root access. So that means we have a root shell. And this slash here tells us where we are on the system. Okay. And it's very common for the root administrative account to use slash as its location. Okay. So let's actually immediately start using some commands to look around in this brand new sort of Linux distro to see what's here. So the first command, write this in your notes, is ls. All right. So ls shows us what is in this directory that we're in. And as you can see, we're in slash. And how do I know that I'm in slash? pwd, print working directory. Add that one to your notes. pwd, show me the working directory, right? And so you can see that there's nothing here. There's nothing to look at here. The next command is cd. cd will change you into another directory. So let's cd into the bin directory, and you see the prompt changed. And now we can actually ls in here, and we can see there's lots of stuff in here, and it's all different colors, right? All right, well, let's go back to where we were. Now, to go back to where you were in the last cd command, you can do cd dash, and that will take you back to wherever you were. If I do cd dash again, it will toggle back between and forth. That's a very common thing to do. We're not going to talk about push D and pop D if you know about it. We're not going to talk about it now. We'll talk about it maybe when we do bash scripting. But if you know about it, please don't stress if we're not going to go over it right now. CD dash usually gets you to where you want to go. CD, it takes the name of where you want to go, what directory you want to go into. So if you want to descend, so, let's go into TMP instead this time. You see that TMP had assumed, because we were in a directory that had TMP, to go into it now, right? So we could go back if we wanted to. And we could also do this. We could also do cd/./TMP. Now, this is where we get to introduce the idea of dot and dot dot. Okay, so dot stands for the current directory, right? / means the current directory. And there are many commands that require explicitly saying in this directory / So you're going to see us do it a lot. And for reasons that we'll get into when we talk about something called the path, but we're not going to talk about that today. Probably next week. So the next thing, so this is identical. So this command and this command are identical with regard to where I was, right? Now, another way to go up besides cd dash goes to whatever the previous directory is, no matter what. But if I'm pretty sure that if I just want to go up one directory, cd .. or cd .. And that means the parent directory. And believe it or not, the ... is an entry in the inodes table. Every one of these directories has a table in the file system that represents every single thing that's inside of that directory. And so inside of this directory, there's an entry that's actually got a name for ... which represents one up. And so that takes you one up in the file system. And you'll see that has the same effect as doing cd dash, because the parent directory is also the same as the previous directory. Okay, so here we are back in here, and we can do ls again. And let's talk about these different colors. Okay, so we have bin is green, this one's blue, this one's a weird yellow color. What's up with those colors? Okay, well, one of the arguments to ls is -l. So if you do ls-l, you'll see the long listing for all of the stuff in here. Every Ubuntu system comes with an alias called LL. I suggest not using it. Just know it exists. A lot of people will recommend to use it. An alias, if you type LL, it'll show you that LL is an alias for ls-alf. And I'm going to show you in just a bit how you can look up what this actually is. You can probably guess already from what we've talked about. If you think about all the different ways to get help about a command without going to the internet, right? The first way we already know, which is ls-h, -h or --help. Either one of those is almost always guaranteed to give you what you want. Even if it scrolls off the screen, it's going to tell you that command and what its help is. Okay, the use of -h or -help is pretty much universal. So that's your first most reliable way to get information about any command. All right. The second way, whoops, that must be capital H. I don't know. That's interesting. It must be -help. I guess that one's only -help because -h means human readable. So -help or whatever. The second way is man, and you'll see man is not working on here. And we're going to talk about why in just a second. Okay, so let's go back to what we were looking at. So here is the breakdown of all the files that are in the root file system of this host, of this container host that we've named Boost as our host name. Okay, so you can see that boot is I'm going to give you a brief summary. If you want to write these down, you can. I'm going to briefly describe what all of these different directories are and why they're named this and the type of file it is, but we are not going to dig into those in depth right now. In fact, many of the types of files, inodes is the right word, but many of the types of inodes that exist are not within the scope of this boost to discuss. And when I get there, I'll such as stuff in proc. But when we get there, I will talk to you about that so you can understand it and you can know where to go to read about it. Okay, so let's digest what all of these things are, and we're going to actually do it in the reverse way because this stuff over here is the most complicated to talk about. So first we see this over here. So this first entry in the root file system is what's called a link, and you can tell that from the L right there. This is specifically called a symbolic link, and it is a separate entry in the inodes table, which, you know, it says that the bin actually points to the directory within this machine for a user. In fact, you can tell that. Well, here's how you can tell. If you ls bin, you see all those files, and then if you ls user bin, same files, right? So that is called a symbolic link, and that is a way of you know, making it so you can see that it goes to. There's something else called hard links. That's what these numbers are here, and we'll talk about those a little bit, but not in depth. So a symbolic link, that's what this is. This here is you can tell from the type over here, it's a D. This is a regular directory. So that means that is something that contains other inodes, other files, and it can have directories and other stuff in them. This here is the date that it was last changed, and that means something in that directory was changed. There are 3 dates that are associated with any inode. There's the date it was created, there's the date it was last accessed, and there's the date it was last modified. Okay, so those 3 bits of information are in every single thing that can ever be saved as a quote file, or an inode is what they call. So this shows you that was when it was changed, April 18th. It may have been, the dates are a little bit weird when it comes to directories, but when it comes to specific files, it's more precise. And you can see these files were all created some time ago. I'm guessing probably, I don't know, sometimes these things are come from the default image, so it could have been a while ago. But if you make a new file, you can see the date be today. So let's actually talk about another command really quick. It's actually, so write this in your notes. So write down touch some file. Now, touch does 2 primary things. One is it creates a new file, all right, if it doesn't exist. So it created a new file, as you can see, and it has 0 length. We're going to get that in a bit. And it has, I did that because I wanted to show you the May 20th timestamp. So that means it was created just now, and that is the file name, right? The other purpose for touch is to update the last updated timestamp without changing the file. So if for any reason at all you wanted a file that had exactly the same content to have its last updated time changed and updated, you would use the touch command. Touch is a really great way to start a new command. There's lots of ways to make new files, but getting into the habit of using touch to make a file will save you from a lot of errors. And when we get into permissions, you'll see one of the errors that will help you avoid is inadvertently trying to go in and create a new file in a place where you don't have permissions. And you'll see later when you open your editor to edit a file in a place for which you don't have permissions, the editor will let you happily create this new file and type it all out and spend 20 minutes writing it or whatever. And then when you go to save it, it'll say, sorry, can't save it. You don't have permissions. And you have to, there's ways around it. You can force it to save to some other location and then change the file permissions and move it over. But you avoid all of that if you try to touch the file before you edit it. So if you touch a 0 length file like this, as a user, it wouldn't do it. It would say, you don't have permissions here. And you're like, oh, that's right. I need to go someplace else to do it, right? To do the editing. Or if I'm going to do it as root or whatever, then, you know to change the permissions up front. And basically using touch is a good practical habit. I see veterans don't do this all the time. I see this all the time. I see veterans like forget that they don't have root access and they create a file and everything, and then they can't edit it and they have to go through all that hassle. I'm like, oh, it's too bad you didn't use touch. So just use touch to create new files and you'll be happy. And so that'll create that new file for you. And I'll give you the timestamp. You'll see this file. This is the size in bytes. We will get into bytes and bits later, but suffice it to say 1 byte is more or less 8 ones and zeros, bits. A bit is a 0 or a 1. And so that's that. If you, by the way, the reason ls-h does not give you help is because it's been taken over to show you the human readable size. And you'll notice he's changed to K, which is 1024 bytes. Okay. So this is, and actually, if we put something in that file, so here's another command, write this in your notes. Echo. What does echo do? Echo just echoes whatever you type to the screen. If you know, most programming, it would be like print. So you can do echo hello, right? And it will echo it. That just echoes it back to the terminal. But you could do echo hello, and you're gonna we're gonna talk about redirection next week. But you can append that to the end of the sum file. And now when we do ls-lh and we look at the sum file, we see that the sum file has 6 bytes in it. Well, let's count. HELLO, that's 5 bytes. Why does it have an extra byte, Mr. Rob? Because there's a byte at the end to indicate the end of either the end of the file or the end of the string. Usually it's a null byte, but we won't get into that. So when you write something, if you're using ASCII characters, which we are, then on average, you're probably going to have files that are going to be about the same size. When you're using Unicode, it's not, and we'll get into that later when we get into a little bit of coding. Okay, so this is the size. Here we have 2 things that are the same, except for here. What's up with that? Okay, so this is the group. Your Naughty Borg is your random name. That's funny. So here we have the name of the group and the name of the user. So in general, in Linux and Unix, when you create a new user, there's also usually a group named the same as that user. Okay. What is up with users and groups? Okay. So on any system for which you can do things, the original Unix on which this was all based allowed there to be multiple users. And those users are contained in a file called etc passwd in every Unix and Linux system on planet Earth. So you can actually look at those with a command called cat and or a command that came more, but cat just dumps the thing to the screen. So we're going to do cat, put that in your notes. Cat temp password. Right, WD. The size of these things is really limited because in the early days, in the early 80s and late 70s, they were limited to 8 characters for file names. That's no longer the case, but that's why they're so short. So you can do that. It's like, oh, did I put temp password? Silly me. That's Etsy. So Etsy, we're going to go Etsy password. So here is all, don't worry, there's no passwords here. We are not going to get into system administration, but I am going to talk to you about 3 files that every Linux system and Unix system has on the planet that are manipulated through other commands, but can also be at your peril manipulated directly if you want. So this file is called Etsy password. Make sure you put that in your notes, okay? And I need to make a call out for this. But as you can see, remember the nobody? There's the nobody user. And we can see that nobody user is a member of the nobody group, right? And these things here, these are the numbers. These are every user has an identifier, a number that goes with their name. And by default, Linux will create new users at 1,000 and up. Usually if they're under 1,000, that means there's some sort of special system user ID. And that's what almost all of these are. Here's us right now, right? So root 0. In fact, it's not uncommon for a hacker to create a new user with a different name and give it the same user ID 0 so that user has root permissions and doesn't show on the system. And, another security person who doesn't know what they're doing could maybe not see it, right? They would see a user and they would just think, oh, it's just another user. But if they have the same user ID as 0, then they would have full access to the machine, just like root. All right. And then we have over here is the default group. This is the default group, not the only group. That's the default group that they're added to. And then we have The home directory, in this case, nobody doesn't have a home directory. And all of these have really weird directories, right? That's the directory that you start in. And we already know about home directories because we talked about it with Git Bash. Same concept, right? Every time you log in, that's where you're going to start. And when you run new stuff, usually that stuff runs from that location. Not always, but usually if you don't specify it. So then we have over here, we have the shell. This is the program to run when you log in. And because these are all special accounts, you can see that they all have no login set. And so that means if you try to log in as one of those accounts, unless you had some way to trick the host operating system to give you a different shell, which you can do if you're hacking, it's going to give you this. Okay, so this is a file. This X here is really, really old. In the old days, we used to have passwords there in the clear, and that hasn't existed for more than, I think, 4 decades. So where are the passwords, right? Well, the passwords are in a file called Etsy Shadow. So if you're a hacker, you probably want to know about this file, right? If you get a hold of this file, I don't want anybody to panic here. There are no passwords in this file yet because we haven't added any. There's the root password is not even in here. But even if I had put the root password in here, it wouldn't matter. Okay. It's the passwords that are put, you're going to see, we're going to add a user and I'm going to show you this again. This is where the passwords go. This star means there is no password. And these are other things related to how long should the passwords expire and stuff. I don't want to get into it. If you want to read about it, again, you're going to use man and that kind of thing. And you can actually do man Etsy Shadow and it'll show you, but it's not going to work right now because man is not there, which leads us to the next thing we need to do. The last file I want to show you related to users is Etsy groups. I always can't remember if it's group or groups. It's group. Okay. And group will show you all of the group memberships to which a user might be a member. Why do we go through all of that? Because I wanted to show you this. Okay. So, and as you can see, we have one last thing to show you here, and then we're going to exit and we're going to create a user. We're going to talk about why, and then we're going to exit and we're going to come back as that user. All right. So this here is the breakdown of the permissions. As you can tell, this first thing here is usually what type of file it is and if it has any special stuff involved. And I'll talk more about that when we talk about this file system, but we're not quite there yet. So, and then you see these 3 octets, right? And these are actually octets if you know about mathematics. So that's base 8. And but we'll just say this indicates where the permissions are. And if you wonder where my name RWX Rob came from, there you go. This is where it was originally inspired. Read, write, execute. Okay. So RWX stands for read, write, and executable permissions. These permissions on directories are different than they are on a file. So you can see here, let's start with the file. It's easier. So you got RW dash R dash dash. If you were to do this in octal, it would be 6 and then 4, 4, I think. Yeah, if I remember right. I have to go look it up. Yeah, in fact, let me try something here. We're going to learn these commands in a bit. I just want to make sure I got that right. You generally don't want to use octal as a beginner, but you might see it written that way. So let's just do the sum file permissions. Yep, 644. Okay. And so if you want to read more about that, you can do man schmod, but we don't have man yet. We still have to add it, which we're going to do. I promise we have lots to do today. So let me finish describing this to you. Let's do the ls-l just on everything. All right. So this says that the owner of the file root can read it and write to it. This says that anybody in group root can read it. And it says that anybody else other than the owner and the group can read it as well. Now, Mr. Rob, this is a container. There's no other users on the system. Why would we have a permissions here? Well, that's left over from multi-user systems where you have thousands of people on the system at the same time, and the only thing stopping them from seeing each other's files are the file permissions. And if you want a peek at that, you can go to Over the Wire Bandit, or you can do the Carnegie Mellon security stuff. You can actually get on systems that have 32,000 users on them, and you'll see the importance of these permissions. Okay. For the sake of what we're doing now, we are not going to go any more deeply into the permissions other than to describe that this is where the permissions are viewed and set, and you can see them. If you want to understand how to manipulate permissions for your advantage, or get fancy with permissions like making a blacklist group, that's outside of the scope for this. But you know what they are now, and so when you see them, you'll know how to handle them. Okay, so if I wanted to change the permissions on that as root, I can do that with the chmod command, and I can say I don't want anybody to do anything with it except for me, right? So I can actually change that, and you're going to need to look up the chmod command yourself, but just know that the chmod command changes the permissions of a file. So you could change we're not going to be doing permissions changing a lot until we start executing files, right? But for right now, let's say I just want to make it so that only I can see it, right? So I could say read write, right? I could say, let's say user equals read write, and this is in the man page for chmod. And you could just say, that's all. Now be careful here, because if you don't do it to the right file, you might screw up something about your system, which is why we're doing it in a container. And now if I do ls-l on some file, you'll see that it's not correct because I did equals and I didn't do it right. Nope, I didn't do it right because I'm an idiot. Let's see, let's do G minus, to be fair, I use octal on everything. Let's try this. I'm going to have to do it. I'm going to have to do chmod-help to look it up. Just so I can help you guys. I use octal, to be fair, but not always. So here we go. So what do we need to do? Changes verbose, octal mode, and the other mode. Oh gosh. Okay, so here we go. UGOA. So let's see. Let's do, all. That's what we want. All equals, actually, no, we want all equals nothing. Now watch. Right? Now it has no permissions. You can't even do anything to it. I can't even do anything to it. Watch. If I try to look at it, I can't even do it. It won't let me. Oh, wait, I'm root. It let me. Oh, that's interesting. That's the first time I've seen that. All right, anyway, so chmod, let's do this. Chmod user equals rw some file and ls-l some file. There we go. So the equals sign is absolute. That says set those permissions to that. If you wanted to, though, you could actually do them additively. So you could do chmod g plus read some file, and that will add this. This is probably more than beginners want to know. Chmod can really scare beginners, but it's important that you understand it. And I'll let you look up the rest of this. You could also do the same thing with octal. So it'd be 600. That would say read write on the thing, and so you can see it there. All right, that's good. All right, let's go on to the next thing. So that's how you change permissions on a file. How would I change the ownership of that file? What if I wanted that file to be owned by a different user? Let's say, what's another user on the system right now that I can look at? We're going to create a new user, but let's go look. So how about nobody? I don't know why you would do that, but if you wanted to make that file owned by nobody, you could shown nobody some file and ls-l some file. And now because I'm root, I'm able to change file permissions for anything. I can also change the owner and the group at the same time with a colon, nobody and no group, some file, ls some file. And so now only nobody can read or write that group. I mean, root has access to everything, but so you see what I mean? So write those are the commands that you need to learn down. Shown and chmod. You can, there is a change group command as well that just changes the group, but I almost never use it. I'm almost always using shown, and then I use the colon notation so that I can add them to, and most of the users that I've seen, the administrators I've seen, that's what they do as well. So there we go. That gets you, how do I change ownership of a file? How do I create a file? How do I change the permissions on the file? This is going to be very much more important when we come to executing files. So let me show you an example of that just really quick. So if we want to run the file as a program, we're not going to do this right now, but I just want to show you why it matters. So if I, let's chmod that, let's chmod plus X, some file, that adds executable permissions to the entire file. And now if I ls some file, we'll see that it has executable permissions for everybody, right? And now it's yellow. That means it can be run. So now I can actually run the file as if it was a program. And it gets a command because there's no such command as hello. But if I change what's in the command, if I put echo, let's say echo hello friend, and I'm writing to the file. I'm overwriting the file, and we're going to learn about this next week. But so we're going to write to that file. And now when I try to run the file, it will actually run because it has a command that works, right? So that's the basis of, now if I take away that permission, minus X some file, and I try to run the file, it won't work. It's like, I don't know what to do. But another way to run a file, that I'll just kind of spoiler alert, is you can tell it what interpreter to use. You can say, well, that's a bash program, so I can run bash dash some file and it will run. All right, so I hope that whets your palate for coding in bash, which we're going to do really heavily in a week or two. But that'll come, the chmod stuff will come back a lot in force back then. So this was all to show you about, what these things are. I know this was a really fast overview. Hopefully you've paused the video where you need to. So let's go back and just talk about what these different directories are. And then we're going to create a user and a group and just a basic user and talk about why you should do that. And then we're going to we've talked about the navigation. So we've been going really fast here. So, cause I don't want to run out of time. So let's talk about what these directories are. The bin directory is where all of the common commands for the system go that are generally available to use to everybody. And you'll notice it's symbolically linked to user bin because historically /usr/bin is a place where user land stuff lives. So if you had a lot of users on this system, things like ls would live there. In fact, let's talk about that. If you want to see where a command lives, you can use the command which and write this down. So which ls, and as you can see, user bin ls is where that command lives. How does the shell know to find it there? Well, stay tuned. We'll do that next week when we talk about path. But that's what which does. Which shows you that that is there. Next thing is we're going to do there's actually two other commands when we do which, and I just want to tell them to you right now so you can write them in your notes. Okay, type ls, which will give you a more precise definition of what actually happens when you type ls enter. You can see that ls is not really running bin ls. It's actually running ls -- color auto, and then that is running bin ls. Okay, so it's really important that you know about the type command and the which command. Type is not a command, it's a built-in, but we'll get there. And the last one is command -v, and I talk about this all the time because I want people to understand these three commands. When we come back to scripting, this will be really important that you understand the difference between these. Okay. And then the last command that's related to knowing about what type of files these are is a command called file. And that just will tell you what type of file is. And this is really important if you're hacking, especially if you're doing over the wire. So we're going to do file, and we're actually, if you type file ls, they're like, I don't know where that is, but we know the full path name. So find needs the full path name. So let's do this. File, and then user bin ls. Okay. Oh, looks like we don't have a file command. Damn. I must have to install it. Okay. I thought file came with it. I guess not. That's interesting. Huh. Okay. Well, that's okay. We're going to go ahead and that's a good segue into what we need to do next, which is install everything. But let me show you something else first. So see how let's do this with type. So if I do type ls, right? What if I needed to give type ls the full path name, right? Well, we haven't learned backticks yet, so I'll teach you backticks later that's going to segue into a lot of stuff. basically there's a way that you can run a command in place and have it replace that spot in the command with the output, but probably too much for you right now. So let's stay with what we were doing. Let's describe these different directories. So bin is where all the commands go for users, right? Sbin is where all the privileged commands go. These are commands that only root or the admins should be doing. And even though the directory is wide open, the stuff that actually, this is because it's a symbolic link. I don't know if you'll notice this, but symbolic links have always got wide open permissions. Do not worry. That's just because it's a symbolic link. If you look at some of the stuff inside of there, so this is full permissions, right? But if you do ls-l, which ls, you'll see that user bin ls has got restricted permissions, So this is the permissions on the directory or the symbolic link, and it's not necessarily the same. And I'm going to leave that to you to go study. You need to go read about what does the different permissions mean, whether it's a file or it's a directory or it's a symbolic link. And if you really want to go exhaustively into that, you can do things like over the wire bandit for free, or you can go get under Linux Foundation, you can go get Linux certified and go through their entire course for free. If you really want to understand baseline Linux and the beginnings of system administration and stuff like that, we are not going to go that much deeper in the boost because we got a lot to cover. Okay. So we want to have you get good on the terminal and know where to go to get more answers. All right. So here we see that permission is on there. Boot. This is where the actual core programs, exist. Boot. Okay. So, wait, what? Oh, I guess boot's empty because it's in a container. That's interesting. Yeah, it's a container, so there's nothing in there. Normally, you'd find, normally inside a boot, if you're on an actual Linux system and not a container, you would find the, the kernel and the init files and the yum files. That's where the real brain of the computer lives. Dev is where all the devices live. So, and remember, as I've said before, everything in Linux is a file, everything in Unix is a file. So if you have a GPU or if you have a mouse or anything, they live inside of dev. By the way, I caught a hacker who tried to set up a rat's nest inside of dev thinking I wouldn't find them, but I was running tripwire process. And so I saw that he changed files in there or that they changed files. I don't know if it was a he. And I was able to catch him. I saw the root's nest and reported him and everything. So, they put an X on the end of one of these things to make it look at the files in here though. So again, be free, explore. You can't break anything here. ls-l, you'll see that all these got weird. What is this? So that means it's a character device. That means it's a special type of inode. These things represent actual hardware devices. They're character special devices. Some of them times they're block devices. So everything's a file, right? In fact, some of these are kind of fun. Like for example, see this one right here, standard out, proc self FD1. Watch what happens if I echo something. If I echo something and I try to write it to, I don't know if it's going to work. Let me try. If I try to write it to stud out, you see how it printed it, right? Echo something is the same thing because stud out is a device. And so anything that you write to stud out gets written to the screen. Standard in is the input for this particular process. These are proc. We'll get to proc in a second. And random is a bunch of random. This is kind of crazy. I might break my terminal doing this. Yeah, let me tell dev random. This is how you generate random numbers. Yeah, it's not going to do it. There it is. You can actually grab random stuff off of the random device to generate your own random numbers. And programs that have random numbers, that's what they do. Dev null is kind of a cultural pop icon. So like your opinion, like this, echo your opinion. You'll see t-shirts that say this to dev null. Dev null is called the bit bucket. It's literally anytime you want to redirect data of any kind and have it just poof, disappear into the ether. Dev null. So there's kind of a pop culture joke about, oh, I here, let's echo your opinion to dev null, or you say something like, hey, let me capture that opinion so that to a file so that I can get to it later. And if they do echo your opinion to dev null, you'll notice they have no intention of ever seeing your opinion again. Because it's going to dev null. This here is related to the terminal. This is a file descriptor. This is the kernel core. And these are the three main streams of input. We'll talk about that when we get into coding. TTY stands for teletype, and that is the thing that's driving the terminal that we're running. That is a device. It's a TTY. And when remember we did the -IT, the T stands for TTY, which allows us to have an interactive terminal that has text. And it actually is inspired by teletype. Oh, there's urandom. I wonder if I did it wrong. Let me tell you urandom. I don't know. Sometimes if we did this right, no, I have to do DD or something. So yeah. And 0 is, I think 0 is the same as dev null. I don't know what that one is though. I'll have to, I don't remember. It might just be 0 bytes. Yeah. Anyway, but these are all special devices. You'll see graphics cards and stuff like that. We don't have very many things in dev because we're just a container, right? But if you had any USB devices, or if you had a hard drive, those kind of things would be in there, right? And okay, so ls-l, we're almost through it. So we have devices, we have Etsy. Etsy is where you put all your configurations, all right? So you'll look at Etsy, and here's all of your configuration files. What is dev null? You just passed LPIC1 and don't know what dev null is? Dev null is the bit bucket that it redirecting to it automatically shuts down. The main reason people use dev null is anytime, like if you're running find or something and you don't want the warning messages to show up, you can redirect the warning messages to dev null, and then it just silences it. So if you run into programs or things that don't have their own way to silence warning output or something like that, you can redirect that output to dev null, and it just won't bother you, and it won't show up in your files and stuff like that if you're redirecting into a file. So here we have here we have all of the different configuration files, right? So like, what is this entity? Is it a program? It's a device. It's a device, and that's why that's why it's under dev. It's a device. It's a character. It's a special device. Every device does something different depending on its purpose. But all devices have standard out, standard input, and you can like change them. So, in fact, some of the cool things about when we get to proc, I'll show you in a second. But you can actually send data to a file and change kernel level parameters of a running kernel. So rather than having something switch to turn on off, it's a file, and then you just set it in the file. Most stuff has a command that does that for you, but under the hood, that's what it's doing. You could actually do it yourself by hand if you wanted to. And if you're a hacker, you might want to know about that. So here we have a bunch of configuration stuff. We have all the different init levels. There's 6 init levels, and we'll talk about that. We have the default RC file, which contains your default configuration settings. I'm just using cat for now. I wonder how big this is. Yeah, okay, so this is the default bash script. This runs every time anybody logs in. So you can see it's got a bunch of stuff here. Host.conf, host name is your host name. If you're going to be doing Linux system administration, you're going to be sent to go edit and change files on Etsy all the time. Okay, so just know that that's where stuff is stored. Our apt installations go there as well. And that's where password was. We talked about that, password and group and all that. Profile is the default profile that everybody gets. But yeah, lots of important information is stored in here. Most of the stuff that's in here is changed through some sort of command interface, but not always. Sometimes you're going to be in there actually editing files, depending on how old the system is. Yeah, so you get that dev null thing. Okay, so what else do we got here? We've got Etsy, we have home. Okay, so home is where all of the new user directories usually are. You can tell right now that we don't have anything in home because there's no users, there's no end users. We're going to add one in a bit. Lib is where all of the dynamically linked libraries are, 32-bit, 64-bit, and x32. This is where, in the old days, there was not that much memory on the computers, so most commands, including ls, were divided up into dynamically linked libraries. These are binary files that are stuffed into memory of the computer when the program runs. And in order to save on disk space and memory space, in the old days, in the new days, everything is statically linked, which means there's no more dynamic linking, which makes it easier because you can just copy around binary files to different machines. This is why Rust and Go are so popular right now in Crystal, because the age of dynamically linking files is kind of dead. We have memory now and everybody's cool with that. But in the old days, you would put all of the libraries that a particular program needed, and it would share those compiled bits of binary across other devices. And they're all in lib. If you're doing any C programming, you probably need to know about that. But other than that, you don't normally need to do it. So an executable program that runs, that's dynamically linked, just runs, it loads that binary up into memory, and the computer sees that it needs all of these other binaries, and those things are already loaded in memory, and it's able to function even though it's a much, much smaller program. But these days, a statically linked binary would have all of those dynamically linked libraries redundantly copied into itself. So it would then go into the machine's memory, and it wouldn't have to have all of those dynamically linked memories on the system, and it would still run. And that means everybody who's there's a little bit of waste there, right? Because everybody who's running the same program uses the same library has now got a redundant copy of that in memory, and so that's very wasteful to the the old school boomer set who set up dynamically linked libraries. But modern development has programs that have statically linked libraries. It makes big old binaries that take lots of memory, but lots of memory in 2023 is not very much. So that's, but if you ever get problems with configuration stuff, it'll be in lib. Media is just this is usually where you would go get your USB mounts. That's almost, or CD mounts or something that would be in there. This is where your block devices, your hard drives and stuff are mounted. We're not going to get into mounting block storage devices at all in this boost. It's a very complicated topic for another time. Opt is a place to put optional stuff. Generally speaking, it comes from vendor land. So like if a package needs to have these files on the system, when it installs, it'll put them under opt. Let's see if there's anything in there right now. I don't think so. No. But when we start to install different things, sometimes that's a place for it to safely, so programs will put stuff in there. Proc is kind of a fun one. Proc is literally, okay, so a process is a running program. All right. And we're going to get into processes when we do scripting later, but proc is absolutely remarkable. This is a file system that contains the representation of every running program on the system. And if you're a hacker, you want to know about proc, all right? Because this is where everything lives. And you see here that here you'll see that we have 1 and 96, right? And we're going to get into processes, but process 1 is the program that was started by the kernel to run all the other programs, right? And usually it's a net or a systemd or whatever. And then 96, that's some other program. I suspect that's probably my bash program. So let's go into process 96 and look around. Actually, wait, what? It's 97. What? You know what? That might have been my program. Yeah, it is. That was literally my LS program. 100. It was my LS program, and then it went away, and now it's still there, right? But so what you can do is you can actually go into these numbers, and you can see all the information about the running process. You can even look at its actual memory footprint. You can see what arguments were used to run it, which is a really great way to get by. Somebody puts passwords on the argument command line. There's lots of really fun things you can do as a hacker here. You can see CWD. Oh, okay. What is that? That tells you what was the directory in when it executed. You can look at its environment, cat env run. Cat, you probably have. So this tells you all the variables that were set when it was run. And I could spend all day in here because, and believe it or not, this proc file system is what the ps command uses. All right. So ps command -a or ps-aux or any number of them. This shows all the running processes. The PS command actually gets its information from /proc. So you can always get the information about the running processes from /proc. That's all I want to say about that. I'm having a hard time because I love /proc. It's really fun to talk about. You can actually change the parameters of a running process and all kinds of stuff. Anyway, so how am I doing on time? We're going to take a break here pretty soon. I hope you've paused the video if you're on YouTube. Yeah, the path variable, where it was run from, everything. /root is the home directory for the root user. That's all it is. And so if you were to log in as root, that would be the directory that you would normally go to. Oh, damn, I got to reattach. So I'm going to just jump ahead here. All right, it's just so I can go back. Okay, so ls-l. So here we go. So we've got root. We have the run. This is the run directory. The run directory is relatively new. This is where things that are temporary go, right? So stuff that gets saved in the run directory doesn't exist usually beyond execution or runtime. Some of it just goes away after, and it's some temporary file system kind of stuff. Not always, but and again, sbin we talked about. There's the file I just made, srv. Sys is like system related stuff. Srv is usually where you put server related stuff. There's nothing related in this container. And because it's a container, a lot of the stuff is just there for the sake of compatibility with other Linux systems, even though it's not being used. Temp used to be a place to put temporary files, and you can go into /temp, and this is commonly where you'll write something that you don't care about, and you're going to throw it away later, right? In fact, when the machine reboots, the temp file should be removed. Now, I have noticed that containers don't remove the file. So, like if I touch a file, touch foo here, right, and I exit, and then I go back into the same thing, it's still there, which I find really fascinating because traditionally the run directory actually I think does clean stuff out for you. I don't know if it does or not. But this is where containers differ a little bit from like a running Linux machine because they don't always behave the same as a machine. Temp is cleared out traditionally every time the system is rebooted. Modern Linux systems will do that by individually removing the files. Older systems would use /temp as a temporary file system so that it was just in memory, and then when the machine went away, everything in it went away. I believe that's the way run is supposed to be now. So, in fact, let's test that right now. Let's do this. So let's say... yeah, and this is where you would write your logs and stuff. Touch foo. I wonder if it just keeps it because it's owned by root. That'd be interesting. I kind of want to find that out. So, but you can pretend foo's still there. So, I think it might be because it's owned by root, but I don't know. I don't know why Ubuntu is doing that. It's kind of weird. Is set up, yeah, temp is a new mount and it goes away, but if it's bind mounts the host the template, yeah. User again is for user related binaries and stuff. The most important thing in user to keep in mind is user share. So this is also a place where packages will put configuration files that are shared, and it's usually named for the application that's there. And then user local. So there you go. There's user local is all the stuff that's for this local machine. So let's say you had several machines. User local generally means stuff on just this machine. Well, in this case, it would be this container. And it's kind of, as you can see, it's kind of a repeat of what was there before. And what I'm trying to find is the logs file. And I'm var log. I don't see var. Oh, is var here? So, okay. So, var is just variable. I don't even know. All I know about var is that var log, you're going to be in it all the time. Var spool is where mail used to be written. var backups. Usually var is a place to put lots of things that require lots of file system interaction and usually really big. And var log, though, is where you want to know. Okay, so var log is where everything gets written. So this is where, all of your logs are. So if your container or your Linux system is failing, you're going to be living in var log and looking for stuff in there. And spool, we used to use spool all the time for mail, cron jobs, stuff like that. So just, that's a general, that still took about 20 minutes, but that is a really whirlwind tour of the Linux file system. So now you know it's there. Now, as a new user, really all you care about is home, right? Because you need to make a new user account. So let's talk about that for a second. So we're going to talk about, and I hope you're pausing the video on YouTube because I'm going a mile a minute here. But in general, it's bad form to do anything as root. And take a moment to think about that. I'm going to ask the question I asked earlier today. I'm going to ask again. Why would you not want to be root? Why would you not want to be root? For what reason would you maybe not want to be root on your own system, on your very own system? Why would you not want root access? Can you think of an easy, obvious reason? Some of you probably already thought of it. The main reason to not be root is that when you're root, you can do anything. And that's super dangerous because there are certain commands that I can do that will destroy this container. And I mean destroy it. So, rm-rf to remove the directory. So what you generally want to do is you want to protect yourself from that by never doing anything as root. Never, ever logging into it. People do because they get lazy. And senior admins will do it all the time, and then they'll burn themselves. And I'm like, damn, I should have done it with another command. And we'll learn about the sudo command in order to run certain commands as root, so that you're protected, sort of, right? Sudo bypasses the protections. But so for the most part, you don't want to do things as root. But Rob, why would you say that when I just logged in as root? Right? And the container world arguably is safer than regular Unix world because you just have a container with one running, user in it usually. But still, why not, for our purposes, let's pretend like we want to do that. Right. So we're going to add a new user, and I'm going to teach you about two commands that are, one of them is very Ubuntu specific, Debian Ubuntu specific, and another one that's universal. And the command is called add user. And the add user is a command. Notice the verb is first, and it's asking for a password. I'm going to type password. Okay. So, and I'm going to just accept all the defaults here. As you can tell, this is a Perl script that was created some time ago for administrating Unix users, Linux users on a university. And it creates the user, it creates a new group. It does a bunch of stuff that you want to do that the other command doesn't do. Okay, and just to give you a sense of that, let's do this. Let's do user add. Let's do user add RWX rub, right? It's like, oh, that one already exists. Okay, well, that's good. Let's do another one. Let's do some user. Okay, now, what is different, right? So this happily added. So let's actually look at etc password again, cat etc password. And you'll see that we have, this one is set up and some user was added. It incremented the user ID. That's good. It did not do anything with this is just the name and stuff. And then it gave it, it set up the home directory. That's nice. And it set up the default shell as bin-sh. Okay. We didn't tell it what shell to use. So add user defaults to bin bash. Now, if I wanted to do that one, then I could have, there's a whole bunch of commands I could have used with user. So let's do that. So user add -h, and you'll see all the different things that I could have done, right? But another thing too is it didn't set a password for the user, and it didn't add it to the groups file. So in general, particularly for beginners, I suggest that you just go ahead and use add user, which is a Perl script. And as opposed to the built-in user add. You should be aware that user add is there, and user add gets called by the Perl script, but it's just generally easier to do it that way. Okay. And so then the next question is, how do you get, by the way, if you wanted to remove the user, there is also del user, right? Some user, and which does what you want, you know, which deletes it, removes it from the groups. And watch this. If I do del user on RWX Rob, it'll do what you want. See, it removes it, provide it, right? Does it still have a home directory? And yes, it does. It didn't remove it. So it did not remove the home directory. It's still there, right? So just keep that in mind. And that's part of system administration. I know I'm going down the road here, but when you remove a user, it does not necessarily remove the stuff in the account. So that's important if you're dealing with security and stuff. But for our cases, we just want a user, right? So we can go ahead and add it back. In fact, if you do add user again with the same name, it'll detect that it's there and say, okay, you want a new password? Fine. But because it did do the password. And I'm going to enter all these empty things. And here we have ls/home is still there, and cat password. We can see that it's back and added there and everything. Okay. So next thing we want to do here is we're going to change into that user. So if you're root and you want to change to that user, you can use the su command. So su dash, and that says I want it to be a login shell. I mean, I want it to be the same as if I logged in as that user. And notice what changed. So here we have the username changed, the machine is the same, and tilde. And we know that tilde means the home directory. So now when we type pwd, we see we're in home RWX Rob. Okay. So that is what you want. 9 times out of 10, you want that. Usually if you might be putting sudo in front of that. But for now, you just know that you're going to become that end user. But wouldn't it be nice if I didn't have to do that every time I log in, right? All right. So let's talk about how to do that. And this is all setup stuff that we have to do before we get going. So, the first thing that we're going to do is I'm kind of doing these out of order in my outline, but the first thing we want to do is we're going to exit out of our container shell, right? And we've created a user there and everything. And so podman images, we can see we got all these images there. Let's see podman PS for the running containers, right? But we want to see them all, including the stopped containers. And we see, oh, hey, there's one called Boost. It's got bin bash. I just barely exited, so that's my container. It's called Boost. Wouldn't it be great if I could make that my new image? Wouldn't that be great? Because I added a user to it now, right? All right, so we're going to take this container. Container is not an image, right? We're going to take this container, this stopped container, exited container, and we are going to turn that into an image that has a default user and a default working directory, that instead of using root. Okay, are you ready? All right, so here we go. We're going to do that. So we're going to say podman commit, and commit is kind of like save or snapshot. And we're going to commit, and then we put the name of the container. You could either do the unique identifier, or you could use your happy name that you gave it. Commit Boost, this is the name of the container, and then the new name for the image, right? Not the container, an image from which we can make containers later. So let's make it, let's say, so podman commit Boost, and then what? We want to have an image, right? We need to have an image name. So we already have, we downloaded, Ubuntu was our first image, right? So let's go ahead and call this, I could call it, since I added a user on it, right? I could call it Boost RWX Rob. All right. It doesn't matter what you name the image, right? So Boost RWX Rob, that means that this is the Boost image that I'm using. It's got Ubuntu on it. You name it whatever you want. But I've added a user on it, so I'm going to put -RWX Rob on there. So, okay, now that by itself is not enough, and we're going to delete it later. I'm going to show you, but I made a mistake here on purpose. So if I do podman, now let's go test it by running it and then deleting it after we make the container. We don't want the container later. So let's go run boost-RWX Rob. Let's make a container out of that image and see what happens. Oh, hey, we got root here. That's cool. And we have home here. Oh, but it didn't start out with that user. And also, look at that. It blew out my host name, right? So a couple things that it did wrong here. Now, the first thing to note, now, because I did, by the way, the RM, I don't have to delete it now. But so the first thing is to note is that you cannot escape host name. All right. So we still have to do host name. boost, right? And frankly, we'd have to do name boost if we wanted to, right? If we wanted to have the container. We already have a container named boost though, and we're going to leave that around for now. So let's just make it have the same host name and have it make, because we did --rm, it's going to throw it away, right? And we're not ready to save it as a container yet. So now we've got, look at that. It made the host name, right? So exit and podman ps-a, you can see that it did not make a new one. We still have the old boost there. But because we made this into an image, we can actually get rid of this other one now. So, you got to be careful though, because you're going to lose that work. So let's try it. So podman rm boost. And this will specifically delete the boost container. Okay. And that's gonna, if you screw it up, you can do it over again, and that's not a problem, right? So now we no longer have that container. So now we can actually do this. We can say, I want my new, I want the new name to be boost. So the name of my new container, I want it to be boost. And now I have boost, and I type exit, and I type ps-a, and it didn't do it. Why didn't it do it? Is it still there? Oh, it's because I did the --rm. Woo! Okay. So in order for it to keep it around, I have to remove the --rm when I'm ready to keep it now. So now when I do this, let's see here. Oh, exit. And you see how my history is even still there? I think that's so cool. So let's ps-a. Okay, now we have a new boost, right? But it's a different one. It's a new one that we just made. And now we can actually reattach to that. We haven't learned this command yet, so I'm going to show it to you. Podman start-a. That starts up a exited container that's been stopped and then attaches to it in one shot. Now you could do start and then attach. They're two separate commands, but if you do -a, it does it in one. So then you do start-a boost and it comes up and you can see the command. You can see that home is there. But Mr. Rob, it still is not making my default user. All right, so we actually have to change some parameters on the image in order for it to boot as what we want. And I know that this is, I didn't go into this 2 years ago with containers, but I'm going to go ahead and go into this at this point. Okay. So there's some things we need to change on this image. So let's do this again. So ps-a. So here we have our container, right? Our boost container. We know that it's not starting up with the default user that we want. And you watch the boost, so you know that you can actually set that. And I'm going to show you how to set it. We just went through the commit command, but I'm going to show you some things you can add to the commit command to make it so that it defaults to the user you want and to the working directory that you want. Okay. So we're going to go through the process of saving or committing a snapshot of our container as a new image. So we're converting a container, running an exited container into an image from which we can make containers later. So let's do that again. So here we go. So let's do podman. So we do podman, and we add, where's our commit? Actually, let's go up an arrow. I already did the commit message, and I'm lazy. So let me find it again. Where's my commit message? So let's see. Where did I put it? There we go. Commit boost rwx rob. Now, how would you even know about this, right? So because you read the docs, right? So -- commit. Let's do this. Commit -- help. Now, when you read the help, you'll see that there's lots of examples here. You can actually change the author, a bunch of cool things. You can pause a container if it's actually running. You don't need to do that. But look at this magical thing. Change string array. Apply the following possible instructions to the created image. And we're not going to get into all the intricacies of containers right now, but let me tell you what these different things are that you care about. I'm going to skip some of them. The most important one is, what user do we want the container to default to? There we go. That's the main one we're looking for. The second most important one is, what working directory do we want that user to start in? Okay. And the rest of this is pretty much irrelevant. This tells you the command to start, which by default has been bash. That's already set. We don't need to mess with it. The entry point is that as well. Command is actually an extension of that. I'm not going to talk about any of those other options. As you learn about containers, you will see what those mean. But right now, all we care about is user and working directory. Okay. So by looking that up, we can do this. We can say podman. Let's go find our commit message again. All right. So we're going to commit the container boost into a new image called boost RWX Rob. But Mr. Rob, you already have an image named boost RWX Rob. Or in fact, let's try it, right? Let's see if I'm going to make it have a mistake. So we're going to do user equals RWX Rob. WXROB. We actually hit a mistake on a bug on this in the boost this morning that we had to spend quite a bit of time overcoming because of Git Bash on Windows. And it came about because I did this. And I'm actually going to force this to have the error, and I'm going to show you how we fixed it. Actually, Frank found this. So as you can see, we get a very cryptic error, and it's like, what the hell is this? And the reason for this is because of Git Bash, and we got around it in two ways. The first way was we went to PowerShell and ran the same command, which is not what we want to do, right? And the second way is we played the Windows game by putting a slash, 2 slashes there. And just in case you're wondering, in the Unix world, when you have 2 or 10 slashes next to each other, it doesn't care. The file system crunches them all down into 1 slash. But this little trick for Windows basically turns off the stuff that Windows was doing to screw up our entry by inserting its own Windowsness in there. And so by putting 2 slashes there, what it does is it says, hey, Windows, get out of here. We actually want to do a Linux kind of thing here. And then it actually does the right thing. And we get a different error now, actually. Oh, wow. It actually overwrote boost. I must have deleted this one. That's interesting. Actually, it either deleted it or it made a copy and overwrote it. But you see here, boost-RWX Rob, that was the image name. So let's reconstruct this podman commit, which is basically save an image or snapshot. And then we want to set this RWX Rob as the user. And we want to set the working directory as home RWX Rob so that when we log in, it's that user and it's that person. Okay, and then this says take it from the boost container and make us a new image out of that container. Right, it gives us the long number, checksum on it. So now when we do podman images, we can see that we have boost RWX Rob latest. What's interesting is that I'm super interested in this. Let me try it again. I want to try it. I think it will overwrite it with a new one. It does. Wow, I just figured that out. That's super interesting. Watch. Okay, you see how this one was made 40 seconds ago and its image ID is 135? Watch this. Oh, look at that. About a minute ago, RWX Rob see how it made a new image ID? Wow. That's new. I just found that out. That's new information for me. What it did is it overwrote the other image with a new one. Now, you may not want to do that, right? You might want to have snapshots as you're going along. For the previous one, yeah. I don't know what none is, honestly. I don't know. I wonder if that's, I think, that's the previous one. Look. Yeah, that's the same number. That was the one that we renamed, and now this one doesn't have a name. Wow, that's super cool. But it still kept it. That's super cool. I did not know that. So I just learned something today. So if you keep the same image name that you previously used, it will happily make a new one and set that as the name and take away the name from the other one, even though it's still there, and you could still refer to it by image ID if you wanted to. That's super cool. I did not know that. So I mean, if whether or not you want to put -1 or 2 or 3 as you're making snapshots along the way, or you just want to blow away the last one and save your most recent image, either way works, right? And you can tell which one it is here. So that is some cool information. I did not know that. In fact, watch, I'll do it again, and I bet you it has 2 nuns now. Yeah, it does. Look at that. Wow, that's super cool. I did not know that. Anyway, so we have an image now, right? So, but now watch. Now we can do all the stuff we did before. So I'm pulling up. Where's my run command? Where's my run? You might want to type them in because, okay, why do we need to do run again, right? We're not doing start because start is for containers that are already there. We want a new container using our brand new image. All right. So we want to use run for that. You could use start and then attach, but let's use run. So run IT. So it's interactive. We want to set our host name. You have to do that from run. You can't do that by setting a parameter, unfortunately. I looked very deeply into that. You can't. So host name boost, and then we want the name to be boost, right? And then, by the way, once you start a container like that, those things are hard coded into the container as long as it exists after that. So you don't have to continually change it all the time. It's just when you create the container from the image for the first time. So run, and it says, I want the name to be boost, and I want to build it off of the image, localhost boost-artifacts-rob. This is going to have an error. Can anybody guess the error? So you can probably guess the error. Okay, so you remember we already had a boost, right? But now that we've committed an image from that container, we can throw it away. So we can do podman rm boost, because we already have a brand new image that we can make as many containers as we want to from that on that. So then we can run it again, and we're going to keep the container name boost, and so now we have boost. And look, all the things are fixed. So now we have rwxrob as our username. We have boost as the host name. And we are now in the home rwxrob directory. In fact, check it. When I go into slash, you remember that sum file? All that same stuff? Now watch. Touch another file. What's going to happen? Denied. Why? Because I'm a user. Now I'm an actual user, right? And I'm struggling. I don't want to show you how to do sudo yet. But if you wanted to do that, you definitely, in fact, we probably do need to do sudo, actually, now that I think about it. Yeah, because sudo su dash, it's not going to do sudo, there's no sudo. In fact, I think we did this out of order. We're going to have to do it out of order because we haven't installed sudo yet. We need to get on there as root. So actually, that's super cool. Can you attach to it as root? I've hit a new bug that I hadn't planned on. Because the last time I did this, we did all of the initial configuration as root, and we forgot to add sudo as a user account. Yeah, we kind of locked ourselves out. This is cool. So because I don't, who knows how to do this? I'm gonna have to take a break. I'm gonna go ahead and pause the video while we figure this out, and then we'll come back. All right, so I'm actually kind of glad that we broke that because we get to see something about the security of containers. And it was kind of a fun reminder to me that I believe, and please let me a comment if you know otherwise, that containers are designed to be run as a user, like the very, very default, and in their very configuration. So what we've ended up doing is locking ourselves out of our container. I don't believe there's a way to start up our container now, our image. Podman images, right? So we made a new boost rwxrob image, and we were very precise in that we took over the user and the working directory to be the user, the unprivileged user, and now that user has no ability to do anything as root, which is kind of cool if you think about it, right? Because that's what we wanted to do, and make it safe. But that image can now, as far as I know, no longer produce containers that can be logged into with any other properties other than that user. Now, it's very possible it can be done, and I just don't know how to do it. Please leave a comment in the messages. But I'm going to show you a workaround that's going to basically use the same techniques for committing images that we've been using all along. And this is fun because I don't have a lot of experience using the commit command before this year, and I've been really enjoying this. So not right now. I'm in the middle of doing some other stuff. So let's go ahead and do this. Let's say podman. So we have our image, right? Our boost rwxrob, and we also have our last working container, which can't be run as root, right? And let me show you what I mean by that. So let's just remind everybody. So podman run it rm boost. Okay, so we're gonna run from the boost, and actually whoops, not run. I meant attach. What am I doing? Dummy. At start dash a. And so this, you see, this is, but now I can't do anything as root, right? I can't do anything as root. There's no root, right? So what we have to do is we have to change. We have to make another copy of that. We have to turn that container into an image again in order to change it back to root temporarily. So this is, I would not have I wish this didn't happen, but I'm also kind of glad it did. So we can do this. We can say podman commit, right? and we want to take boost. Actually, this time we just want to change the user, and we want to make the user back to root. And let's change the boost image, the container, and we're going to turn it into a temp image. This is not going to be our final image, okay? Because we're going to make another image that has the default user of RWX Rob on it, okay? Not right now. No, I'm in the middle of doing the boost. So let's do temp boost right now, and that's just going to make a temporary image. All right, and so then we do podman images, and we see that we have a new temporary image, temp boost, right? And we're eventually going to throw boost-rwx away, Rob away, or we're going to update it. Okay, but the reason we did this, we needed to get root access back. Okay, so now we can do this. Now we can say podman run -it, and we want to keep it around, so we're not going to remove it, and we want to run it. And let's go ahead and take the host name again, make the host name boost, and we'll make the name boost. Actually, we already have a boost, so we might have to remove the other one. In fact, yeah, let's do that. Since now that we have the temp boost image, we can remove it. Be careful what order we do this in. So podman, and now let's do the rm boost. That's going to remove the boost container. All right, so now we can do this. Let's say podman run it and dash hostname blah, 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 boost dash name boost. And then we're going to make it, we want to build it from temp boost, which we're going to replace that image later. So that should do it. Let's go ahead and do that. Okay, now that gives us back our root access, right? Now we still have RWX Rob as our home working directory, and we have an RWX Rob account and everything, but now we have root. So we can do a couple of things that we needed to do in the first place. So the first one is, let's actually simulate the problem again. So I'm going to change into the RWX Rob account. And now how do I do stuff, right? Well, I can't sudo, because I don't even have a sudo command. Okay, so believe it or not, if you read the outline, I jumped past two really important things out of order, and I'm kind of glad I did, so I was able to hit this error. But these are, pay attention, because this is how you take a minimal Linux Ubuntu container, and you make it back into a pseudo, distribution of Ubuntu. And I don't know if you saw, but every time we've been doing man, it's been telling us how to do this, right? Now, this is an Ubuntu specific thing, but it's pretty useful. And as long as we're logged in as root, we can actually do what it says, and we can run unminimize. And what that is going to do is it's going to install a whole bunch of packages, and packages that you would not need if you were doing, lightweight containers. But in this case, we're making a workspace container that we want to use for documentation and, kind of a lighter version of a virtual machine. It's not quite as heavy duty as a virtual machine, and you'll see how we can actually share these things with others and publish them to GitHub and all of that. So let's keep going on about that after this installs. So if you haven't got a GitHub account, please go ahead and make one. We're going to use that after this. So here we've got everything on here. Now, the thing that's ironic is that there's still no man command, right? There's all of the stuff there, but there's no man. And so we're going to use the package manager. A package manager is the way that you install and remove software from a Linux distribution. And the reason we picked Ubuntu is so that we can use apt, which is built on Debian. It's very common. And before you can use apt, if I go to apt install man, it's not going to do it. Actually, in this case, it already updated it. But generally speaking, what you want to do instead is apt update, not upgrade, update. And what that will do is that will go, when we did unminimize, it kind of did it, but when we did unminimize, it did it for us. But if you're ever on a container that you're about to install something with apt, it's good to always do apt update. What does that do? That grabs the most recent listing of all of the protected packages in the Ubuntu ecosystem and puts them on your computer. And you can rest assured that installing anything with apt by default without any other modifications is fine and safe, because enterprises all over the world trust it for that. And, they pay a lot of good money to make sure that Canonical and Ubuntu maintain those lists of packages, even if they're slower at getting them out. And in the other boost this morning, I actually talked a lot about why Arch and the Arch user repository is appealing to other Linux users, but it's also the Wild West, and there's no way that'll ever end in an enterprise because it's too dangerous, right? There's nobody checking it out there. And Debian has adopted something called the Debian user repository as well. But so the takeaway from that is apt update makes it so it gets all this stuff, and then apt search, if you wanted to search all the stuff that has man in the name. But most of the time it'll do a pretty good job. It's actually downloading the index so it can do its searching in all of the packages that exist in the world for Ubuntu, and it'll find the things that we want. And this will just tell us that the command man is actually in a package called man-db. But a lot of times apt is smart enough to figure out that when you try to install a command, it'll be like, oh, you actually want this package, and it'll help you out there. So if it doesn't do that, then you need to know about the search command. You give that a shot. So we're just about there. Why do we need this, right? Because we need, wow, look at all that stuff. So let's try it again. Sudo apt, wait, no. Normally you would be typing sudo because you want to do it as root, right? But we're already root. So apt install man. That's going to install the man command so that we can get the documentation about everything. So we talked about -- help. We talked about, -h on occasion. And now we have man. So you can do man ls and you can see all of the stuff. Now, by default, this thing down here is saving it for us. So we can push, space and it'll page down as we go. So we don't have to scroll, right? That's good if you don't have a terminal that does scrolling. That's called a pager. The default pager on Linux and Unix is more, which is not very good. So the next package we'll install, apt install less is what it's called. And less is a better version of more, basically. And now when we do man ls, you'll see that it's got quite a bit of different stuff down here. And that's because it's using a better pager. So the note here is install less, it's a better pager. And instead of using cat every time, you can now use a pager to look at files. So you remember we were looking at cat etc password, right? We were looking at that instead of, see how it scrolled off the screen? So if you wanted to, you could do less etc password, and that would actually show you all the files, and then you push space and it'll show you the ones at the end if it's more than one page. So I wonder if groups is bigger. Push the up arrow, etc group. Yeah, okay, so group, you see it goes off the screen. You can push space and you can go through them all. So anytime you have content that is more than one page, you can type less. And actually, if you type more, it's still on there. More is still on there too. And then I'll show you later how you can make, whenever you use the more command, it actually uses less instead. Or you can set the pager environment variable. All of that is in bash configuration, which is several weeks away. So here we have root, right? We've installed man, we've installed less, but we still need that sudo command. What is sudo? In fact, if you want to go have some fun with this, go look up sudo make me a sandwich. And this will be just my chance to introduce you to some pop culture. I know this has been very dry today. This is you can get this t-shirt, make me a sandwich, make it yourself, sudo make me a sandwich. Okay, so sudo command means do it as root. All right, now you have to be given sudo permissions, but remember we talked about not doing things as root to protect yourself. Well, when you actually do want something to do as root, do it as sudo. And so the way you protect yourself is you give your user sudo access. You'd be like, well, why not just have root access? Because most of the time you don't want to do things with root permissions. You want to do them with just basic user permissions, so you're not blowing away your home directory or the entire root directory or something. But when you specifically need root access, then you can use sudo. And so we need to have the sudo command. We don't even have it right now. So apt install sudo. We're going to put that on there. And there we go. There's our nice sudo command. So now we can do sudo su dash. And it worked, right? Because we're root. So root has sudo access already. Now, the last thing to do here is, okay, a couple things here first. Don't confuse sudo with su, all right? So su says do something as a user, all right? So su, and because I'm root, it'll go ahead and log in and run a login shell as me, right? If I wanted it to do a specific command, I could do su-rwx-rob/c date, and it would run the date command as root or as rwx-rob, right? But su-rwx-rob says login as that user, and that's very, very common. You're gonna be doing it a lot. Make sure that's in your notes. And because we're root already, it happily does it, and it puts us over here, right? Now, the whole point of putting sudo on there is so that we can do things as root. So we might want to say sudo echo hello to to a file that's in the root directory, some file that we don't have permissions to, right? Permissions denied, right? Why not? Because in order for sudo to work, a user has to be added to the sudoer's permissions. And I don't want to go deep with this. There is a file that you can go look at if you want to, called the sudoers file. And this file, if you become a system administrator of any kind, you'll have to know it. Okay. This file has got a complicated configuration, and this is how you administer all of the things that have permissions, right? You don't care if you're just a beginner, but the thing to know here is that sudo is able to make it so that a specific user can only run certain commands as root, okay? And that is sudo's primary purpose. So let's say you want to give me permission to just do the ls command or something as root, right? That would be how you would do it. And believe it or not, we use this for lots of things. We use this for at work as a way to use SSH as an API protocol that in a safe way, using a safe shell that doesn't do parameter expansion in order to run remote commands over SSH through a login shell of a specific user that only has access to specific commands. So the takeaway here is sudo is mostly to help control what can be run as root by a specific user. Now, what we're going to do is very commonly what is done in the administrator world, we're going to give blanket access to rwx-rob as a sudoer, as root. So rather than doing everything as root, we'll let rwx-rob do anything with the sudo command as root, including starting up a root shell if I really want. So the way to do that is to add rwx-rob to the sudoers or to the sudo group. And if you want to see the group here, we haven't learned grep yet, but if you can go grep group, you can search for sudo from here, and you can see that there's a group there, right? Now we're going to use another command you've never used before. It's called user mod. So we're going to do user mod. We're already root, so that AG, I'll let you do man user mod to read about it if you want. This says, I want to add this group to this user. All right. And now rwx-rob is in the group. Let's actually go log in as rwx-rob. And now let's see, try to command as run a sudo root sudo command. Yeah. So now watch, we can say, I think it's groups. I think you have to do login. So see, if I run the groups command, another one for your notes, that tells you what groups I'm a member of. I'm a member of the rwx-rob, and I'm a member of the sudo group. And so now I can do things as root. I can do sudo, where's my echo command? Let me go up and see if it's still there. There it is. So the sudo group is built into Ubuntu. Yes, it's not built into everything. Other Unix systems, you might have to edit the sudoers file, but Ubuntu, the sudo group is there. And we confirmed that before we did this by showing the Ubuntu. Here it is right here. How to add user to the sudoers in Ubuntu. You can either put them in the sudoers file, or you can add them user mod to the sudo to the group, right? And so here's a command I'm about to do. If I were to do the command without sudo, I would do echo hello, and I would type to /muhaha, right? That's in the root directory that's owned by root. You know, that should not be a place I can be able to mess around. Users should not be able to write to that. And sure enough, they can't. But if I say sudo make me a sandwich, sure enough, I am blocked again. Look at that. Why am I blocked? That's interesting. I should not have been blocked for that one. Oh, I know. It's because it's the redirection. Yeah. I had to put that into a script. Yeah. because it doesn't give me permission to the direct. Redirects are not covered. I forgot all about that. That's a regular problem. If we do, I think anyway. So let me try something else that I can do that I normally couldn't do. Let's try this. Let's go into the directory. And let's try to make a file. This redirect right here, we haven't covered redirects, but redirects are not covered by sudo. That's why it's not doing it. So let's try it. Let's see another way I guess show you this. Touch, muahaha, permission died. And now let's do sudo touch. And then it asks me for my password. And if you type the wrong password, watch what happens. This is kind of fun. I'll type the wrong one. Yeah. Oh, it didn't do it. Damn it. Wait, here we go. It usually will give this really, really annoying message, like it scares you to death. Oh, it didn't do it. Sometimes it will say, "This attempt at modifying root permissions has been logged and will be reported." It like really scares you. So we have to type the password. So prove that's me. And I'm going to type my password. Doom disk will be destroyed. There. Now watch. Sudo touch, and I would do ls. Muhaha. Now look at this. Look at the permissions on this file. What? That's right. Got root. So because I did sudo, that command touch ran as root. The other one didn't work, as I said, because of the redirection. Redirection is not covered by the sudo. You have to do some you have to put all that into a script to do that, which we haven't covered yet. So here you have lsshl muha, and you can see that file has been changed. But more importantly, let's say you have a lot of commands to do, and you say, I just want to do it all as root, right? So you'll see this a lot. Sudo su dash, and the default is root. So you don't even have to put root here, right? So you see sudo su dash, and that does this. And now you have root, and you're in the root directory. You notice how you're in the root home directory, and you're not just on / like you were when you started the container. That's because it's using a login shell. It's using dash that says do it as if you were logging in as root. And so now you can do whatever you want as root in multiple commands, including echo something to mu ha 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 ha. And now that'll work, right? Because the redirect is happening as well as just the echo. I don't need sudo for that. And if I type exit, it'll go back to the end user. So you can go in and out of root as necessary. And that is really the proper way to do systems administration, even in a container. And you've been hacked. So now that we have got, the reason we did all of that is because we wanted to give our RWX Rob user access to the root account before we save our image. You remember we locked ourselves out of it before, right? So now we can kind of back up and we can go to that step. So let's go back out and we'll exit out of our container. And so now we're back on TV, which is my Windows machine. And you can see that podman ps-a, you can see boost is the one that we just got in 11 seconds ago, and that is the container we were just playing in. We could go back in there and confirm it, but that's the container that we now want to make a new image out of. All right, so it's making containers out of images and images out of containers, right? It's back and forth as the freezing of stuff. And so let's actually do that. So podman what is it? Images. Let's just show all the images. Okay, so we have temp boost, right? That is the image that we used to do this, but we really don't need it anymore. We're going to be throwing it away in a bit. What we really want to do is we want to update boost RWX Rob to be this new container that's got all of our sudo and everything in there, right? So let's do that. So let's see if you can remember the command podman commit. And we're going to, now don't forget to put your C's in here this time, right? Because we want to go back to having it be a restricted container, right? So user equals RWX Rob. We already have the workspace is still set. We don't have to change that. That is already in the container saved that way. So I don't think we have to change that. So that, remember it defaulted to home workspace, right? Or to home RWX Rob. So we got that one in there. Now, I mean, if you want to, just for good measure, you can workdir equals // because Windows git bash home RWX Rob. So that's who's going to be our default user to log in. And then what? And then we want to tell it what container So we want our current boost container, and we want to tell it what image name we want it to be, and we're going to override RWX rob. So when this command is finished, it'll take our sudo configured boost container and it will turn it into an image that overwrites our existing boost RWX rob, and this old one, 6df, will become an unnamed image. Okay, so when we run this, we can run it like this, and it's going to take a while to do that, considering it's 80 megabytes. I'd be interested to see how big it is. Podman images, because we actually unminimized. Yeah, look at how much bigger, 144. But as you can see, there's D2D. Our old one has now been unnamed and orphaned. That's fine. We can delete those later. Hey, Twisted C. So we have boost RWX rob. Now let's actually test our cool image, and we'll be done for today pretty much. We've talked about a lot for today, way more than 2 hours worth, and a lot of you free to go out there and practice. And the last thing we're going to do, if this works, is we're going to actually save our image to GitHub so that you can use it anywhere. And so what we're going to do is we're now going to say, Podman, we got to make a new container out of it, right? This is take two. I'm trying to make it faster than the other one, even though it's still long. And I'm losing my voice here. So let's go ahead and do this. Let's do Podman. Okay, so let's look at all our images again. So now, if we're confident that the other one works, we can throw this one away. I'm so confident I'm going to go ahead and delete it. Podman RM boost. That's going to remove the boost container, not the image, the container. So that removes it and gets it out of the way. And now we can do podman run, which creates a new container out of the image. We want an interactive one that has a TTY or a terminal. And then we don't want -rm because we want it to stick around, right? We want to keep using it. So we're going to leave that off. And then we're going to say that we want, what image do we want? Well, we want boost RWX rob, right? And this should actually, no, we forgot the base name and the host name. That has to be done too. Host name boost, that has to be done on the run command for reasons that I don't want to get into. It's big. It's you can't embed host name information inside of your images, unfortunately. So, but after you start a container, it's permanently, engraved in the container, more or less. You can change it, but it's really hard. So when you run, when that starts the container, makes a new container, which is a version of the image, one instance of the image, and then it burns into it the host name and the name, so we can refer to that from now on. And then we can use that container to make another image later if we want to. But for right now, that should be enough. So now here we go. So we can run clear, and we see what we got here. Can we go into here? Yes. Hey, we still have Muhaha. I got burned in there too, right? Let's try to make a Muhaha, shall we? So let's say touch. Really? How about that? Uh-oh, permission died. But watch this. Sudo touch. Really? Oh, it wants my password. Well, my password has been hard-coded into the image. That's kind of cool, actually. That is kind of cool. So you better remember your password. You know what is cool about this that I just realized? That even if somebody got a hold of this image, if you set it up like this, they can't. Oh, wow. I typed the password wrong. That was weird. Yeah, I typed the password wrong. So if you set this up, properly, even if somebody got a hold of your image, because if you keep the password secret for the account that has sudo access, your images are protected, which is pretty damn cool. I'm sure there's a way around that. I would want to have some hacker show us the way to get around that. But I think there might not be a way to get around it. So that would be a challenge to someone. Can you get around my security? So like if I give you a copy of this image and you run it and you don't know my password, can you do stuff as root in the container? That'd be a fun challenge. I haven't played with that. And this is, again, the whole purpose of this is to do that. Well, so here's that image. I'll go ahead and exit. And now rather than doing run, we can just do podman start -a and the same name as boost, and it just drops me right into there. Okay, upload that image now. Actually, I'm going to. I'm going to make it a public image. Okay, so let's do that. Let me show you how to upload your images to GitHub. Okay, now we're not going to upload images to Docker Hub. As far as I'm concerned, Docker is dead, and I don't use it for anything for reasons I've talked about before, and I don't want to get into again. But Docker as a company is just collapsed pretty much, and anybody using it is going to get burned. And so I don't want to teach you how to use it. I want you to have you use GitHub instead. You've already got a GitHub account. So, and not to mention the fact that GitHub does the security management so much better. So we got this beautiful image here. How do we save it and share it so that if this computer dies, I can use it someplace else? Or let's say I install Podman on a different computer and I want to use this image that I've been building and I want to use it on that machine, or I want to use a copy of that image on that machine. How do we do that? So we do Podman images to show us all the image, right? And here is the image. You can, boost RWX Rob. That's the name of the image. And we have latest here 5 minutes ago. And you're going to be able to use my image actually, okay? Which is going to be fun. I'm going to actually share it by making it public. Now, if I were going to use this on Docker, so I would just do Podman push. So we did pull to pull down Ubuntu. Remember that image? We pulled it off of Docker Hub. Now we're going to use push, and I'll just tell you right away, if I use push just by itself like this, I could use RWX Rob / boost RWX Rob. This will push it to Docker Hub. Actually, I wonder, oh no, so I have to do boost - RWX Rob. If I wanted to push it to Docker Hub, I could do it like this. Okay, so since there's no registry, it will push it automatically to Docker Hub. Now, Docker Hub puts things up there as public by default. And I want to, I'll go ahead and show you how to push it to Docker Hub to do this. In order to do this though, you have to log in, and that's a step I didn't show you, and it's pretty big here. It's interesting too that all these blobs are different save versions. Every time we did a commit, it saved another blob. That's kind of cool. So anyway, if you go to Docker Hub now, you can go see it, and then I'll show you the other one. So where is my Docker Hub? All right, so here is all of my images. You can go to hub.docker.com/repository/RWXRob, and there you go, public right away. So those of you who want my image and you want to go hack on it, you already know the password is password, so you don't need to. But I'd love to see if you can get root access to the thing without knowing the password. That would be my challenge to the hackers out there. Can you grab this right now? And by the way, if you wanted to do that, now we can do something completely differently, right? We can do it just like, we can say podman run it -- rm RWX Rob / boost - RWX Rob. Anybody out there can do this right now, right? So, because I have now shared that image with the world. Anybody in the world can now grab that image because it's public, okay? And you can try to break out of it and do whatever you want to do over there, okay? So as I said, it's a great way to share your images with the world, or with your friends or with yourself and everything. But I also want to show you how to publish it to GitHub. So that was Docker Hub. I wasn't going to show you that, but it's so easy. Might as well. Now, before you can do that, you have to do this. And I'm just going to show you the command. Podman registry. This is a new command. Is it register or is it login? So podman login docker.io, right? Already logged into docker.io. Okay, so you need to write that in your notes. All right, podman login docker.io. Now you have to have an account over there, and in order to push, you have to have authentication, right? To log in to the GitHub repository, you need to do GitHub container repository.io, GHCR. Okay, so you can be logged into multiple registries. There's all over, to Quay.io, that's in the Red Hats. These are places where you can push your container images and share them with others or yourself or whatever. And by the way, if you're working internally and you've got like a Harbor, say you've got like a Harbor registry that you're running in your home lab or at work, you can take that image and push it to there as well, right? So, and all of those are going to need you to log in. Now, I'm going to go through how to log in and do the GitHub stuff very quickly. I'm not going to show you anything because I would give up too much of my information. So when you do docker.io, you're using your username and password, right? Which I think is unsafe, but that's how Docker.io does it. When you do it on GitHub, you're actually doing something called a user authentication token. And the way to do that, there's lots of documents about how to do this, but I'm going to give you the overview. All right. So, in fact, here's a really good document that covers it. This is on the GitHub docs. It shows you how to do it. That's viewing, I think. Yeah. This is the one. Okay. Creating a personal access token. Okay. This is a little tricky. In fact, I'm just going to give you the link, because I don't want to show you, my personal access tokens. I don't want to make a mistake. A personal access token is as good as a password, and you can make them so they expire after 30 days. You can make them so they never expire. They're basically temporary passwords for your user ID, right? And they are much safer than actual passwords, right, to the account and stuff. And since GitHub, generally speaking, doesn't like to use login, password, and username anyway, I think they require certs now, SSH keys and stuff like that. That would be the way to go about doing that. I'm trying to find a way to paste this to you here. So let's do paste. So you can go read that. And so step one, let me delete this. Okay. So step one, this is how you see it. All right. Step one is to go into here and click on your username, and I believe it's under settings. In fact, let me flux this. I want to be sure to tell you correctly. I just don't have to read this whole, I don't want to have to read this thing. Anyway, you need to add a personal access token. Just go figure that out. And I don't want to risk it because I don't want to ruin this whole video. So once you add a personal access token, it will have you copy it into your copy and paste buffer, and then it will never show you your personal access token again. And you need to, if you want to keep it safe, you should store it in a file on your system somewhere that you trust. If not, once you log in, you don't really need it. In fact, you could even go add another personal access token later and log in with that one if you want to, and then undo the other one. And that's one of the reasons. Here, let me show you something. Okay. Just give me 1 second. I want to show you this, so I'm trying to get to the point where I can show you. Alrighty. Dang it. I had it set before. I'm playing with OBS. I am so sorry. Okay, here we go. Yeah. Yeah, let's turn this on. It's not working. Okay, there we go. No, I guess not. Oh, well. There's something else above that. Yeah. Hey, hi. All right. So anyway, I guess I'm not going to be able to turn my flux. I screwed my flux up earlier. So just go there, add a personal access token, and use that as your password. Okay. If you have any problems with that, look it up on GitHub, and that's the password. So when you do the login here, ghcr.io, it'll prompt you for your username and your password, and you'll type in, in my case, RWXRob, and then when it comes for the password, you paste in the personal access token you've added. The key thing to remember here is that your personal access token has to be given permissions to packages, and write and read permissions to packages. And that's the piece that you'll need to go read about. Okay. So here this tells you about personal access tokens. But that's the key, right? And you want to do custom. You want to do the old one, not the new one. I wish I could show you that. I'm really sorry. I'm just too scared to show you my stuff. And then once you have that, you can go ahead and share your image. And by default, I like this about GitHub. By default, GitHub shares your containers as private packages. So, and the way to do that is relatively easy. It's that same push command, but this time I'm going to do ghcr.io/ right? And this is going to go ahead and it's going to push a package. It takes about the same amount of time, but this is pushing it to GitHub instead of to Docker. All right. And it's going to be the last thing we're going to do today. But then once you do that, so there it goes. Then you can go back to GitHub and you can go on my profile page. And if you refresh, this is my profile page on GitHub. You can see that there are packages now because the name is the same as the other one. All it did is update it. So you can see that, oh, wow, it didn't update the number there. It should have. Maybe that's just a new one. So you see I have blob hashes for integrity. Yeah, it's not a secret. Those aren't secrets. So then we have Boost Week 3, and that's the one I was doing before, which I can actually delete. I don't need that. You can actually click on it and decide if you want to delete it. It tells you what to do with it. This is not one that I need anymore, so I can go ahead and delete it. The thing that's really cool about GitHub is you can tie it to GitHub Actions so that we don't know about, you know, I'm going to do this yet, but you can actually make it so that your GitHub repo that has source code in it actually can be generated into a container anytime you change it. But in this case, we're just pushing our ongoing images and we don't really care, right? So we have Boost RBX Rob and we have it, see it says private. So that means other people can't see it. I could change the package settings over here and make it public. But you already have the one on Docker, so you can go look at that one. I'm going to leave this one private for now. I don't know if that should add repository actions, repository, no. Namespaces, no. Manage access role, remove, no. Change the zone, change visibility. So this is one of the things I do like about Docker. I mean, about GitHub over Docker. The default for your image. So I plan on actually using this to create a workspace container that has a password that I have to log into that contains stuff in it that allows me to do everyday work, right? And because it's encrypted and, you know, but like app tokens and stuff like that. So you can actually use this to manage your workspace kind of everywhere. And in some sense, you know, make it secure. You get, as long as you put passwords on stuff and save stuff encrypted on your image, you can actually create images that are workspace images that contain secrets and stuff that you might want to use that are stored up on GitHub, as long as those files are protected, and in our case they are. So then we do change visibility here, and as you can see, I'm going to make it public, and I'm going to change boost-rbx rob to be public on the GitHub container repo. Now it calls in packages, you can store npm and all that, but this is just a container. So if you want to use that instead, you don't have to have, you can use my that container immediately, just like we did before, by doing run it, but now you can do a ghcr.io, and now it'll actually run my container from there. Now I do find it interesting. Oh, look, I forgot to put what boost name in it, so it gave me a random name, which is fine. It's a -rm. It's going to go away afterward. There you go. That is it. That is a lot to cover today. We've been streaming for 2.5 hours, even though I talked a lot faster. We covered a ton today. So you might have to watch this video multiple times. You might have to stop it several times along the way. I mean, seriously, we covered a lot of content today. You know, we just to recap, we're gonna be up on YouTube. We covered even more than what's here, but we covered the which command. We covered the file. We want to install the file command. We did ls, cd, chmod, shown. We covered all that. We talked about deleting and adding users. We talked about how to commit images. We talked about creating a personal token, and, you know, using paid pages and pushes. So we've talked about everything necessary to continue with the boost. Okay, so if you want to know whether you have grokked everything. Grok is a term from Rabbi Heinlein. It just means to understand deeply from the Martial Chronicles. But it's a word that gets used all the time. If you want to know if you've grokked the boost for today, just know that you need to be able to use Podman to create containers and images from containers, or vice versa, and to be able to push those images to GitHub and or Docker so that you can share them with yourself and with others. And that is going to give you the ability to feel safe when we do some of the more dangerous things later, such as like deleting entire, remember all those directories we went to? What happens if you try to delete /proc? I don't know. Let's try it out. Now that you know how to revert back, anytime you do something to a container, you're just affecting that one container for the most part. You're not affecting anything outside of the container. That's the whole point of containers. The whole point of containers is somebody who wrote a stupid application could totally screw it up. And the system administrators who are really picky, the bastard operators from hell, they're really picky about putting that stupid application on their machines, they can feel safe knowing that, and that's what DevOps means, dev and ops coming together and being happy with one another. You can run anything on my systems as long as you put it in a container, right? And then the operators can decide what the parameters are for those containers, how much memory can you use, how much CPU, whether it goes problem. If they know that if it goes wrong, it's not going to destroy the host system that those operators have spent so many dedicated hours keeping up. Right? Their precious host system. That is why containers are a thing. So you can benefit from that containerization in your exploration by destroying crap all the time. You can just go in there and like randomly destroy things and you are not going to touch the host system. Right? Now be careful that you're not in Git Bash, because Git Bash is host system, right? Git Bash by itself, if you're not in Podman, connected to a container, you are in the Windows machine and you don't want to mess around there, right? Even though it looks the same. So make sure you look at that host name. That's why we put boost in the name, because that way you're safe, you're in a thing. And even if you totally screw up a container, you always got the last image that you saved, that you committed. That last image is always available for you to go back to. And even if you screw up that image, you can go all the way back to Ubuntu and practice installing from scratch all over again. And that's the repetition that you need in order to learn this stuff. And we now know everything we need to know to really start being dangerous and to start writing scripts, to start writing, to learn Vim, to learn how to manage terminals, to do command line searching like a boss from the, from the command line, searching for the command line. You're going to learn how to code in Bash. You're going to be really good at coding Bash scripts before we leave. We're going to sample the coding in Python and C and Ruby and Go, maybe a little bit of Rust, just to show you what you would need to do to compile that out. We're going to actually use this whole commit idea so that you can actually take that baseline container and say, ooh, I want to make a container just for developing Ruby. I want to make a container just for developing Go. And then that container can just have all the Go tools on it. But the other container images, guess what? They can have all the stuff just for C or whatever. You don't have to put all that stuff on some big monolith container, and you can use that same base image that you learned how to commit to make all these different development environments. And you can know that is how development happens today. People are commonly making development containers that have all of the dependencies for that project. So if you are a hardcore software engineer, you'll be right at home when someone says, here's our development container. And they will give you a container image and you'll be like, that's all cool and everything, but I want these tools in there and you don't have them. Well, now you know how to take that image and commit it and add your stuff to your own version of the image, right? And if they decide to update theirs, then you'll have to decide how to update yours. And that's where having a Docker file and that kind of thing becomes valuable. But for now, you don't need to worry about it. You just need to know if you want to add something to it and you want it to be there all the time, you know how to do it. You can go in there and you've joined the no more work done on my machine. And that is exactly the point of containers. Not to mention the fact that once you've containerized everything, it can now run anywhere containers can run, including the big massive behemoths like Kubernetes. And my screen is acting weird now. Is this a virus? Yeah, RM-RF. Yeah, you don't want to do that on your own host system or even a virtual machine, frankly. That would break it. Now, virtual machines have almost exact equivalence to the things that we just did. It's just a little bit more hairy and usually dependent on the proprietary software offering that is coming. And believe it or not, VirtualBox is proprietary software, even though they give it to you for free. So, I mean, it's very much controlled by Oracle. You can say it's not if you want. That's fine. So this is the end of this YouTube video. I'm going to go ahead and stop it now, and I'm going to stop talking. I've been talking for 3 hours straight. I'm losing my voice. And we've covered a lot, and I feel bad. Chemo all the way. Yeah. I hate Oracle. Me too. So please go ahead if you have questions about any of this, because it is a lot. I'm not going to lie, but every ounce of the stuff that's in today's conversation is relevant to pretty much every tech job on the planet, because this is fundamentally how to use containers to your advantage. Whether you decide to make containers or not, learning how to use containers is baseline kindergarten tech skills. If you don't know how to do that in modern 2023, you cannot function as a technologist. There, I said it. Okay, it's SKILSTAK if you're looking for that. I did want to say a couple things as we part. If you are in the greater Charlotte area, we have distributed something like 3,000 SKILSTAK shirts, like the one I'm wearing right now. It says "Learn Code, Save the World" on the back, to Goodwill, and those may or may not be available for purchase from those Goodwill. We decided to empty our storage unit, and rather than try to sell them through here, we just went ahead and distributed them regionally. If you happen to be somebody who has discovered one of those SKILSTAK t-shirts from a local Goodwill, please let me know. We have a few dozen, maybe a box or two that are here at home if somebody's really insistent on having one. But otherwise, if you are insisting on getting one, please direct message me. But I just wanted to say that because I know some of you are local. So if you want to watch your local Goodwill retailers, for those, you can get those. We didn't make any money on them. We just donated them just to get them out of our storage unit. That is all I'm going to do for today. And we will be, I'm going to promise you we're going to do 2 hours next week, but this was a big one. We needed to make sure this was all here. So goodbye, YouTube.